Hey everyone, so we're here looking at some skills that are needed to be successful in Unit 9 when we examine polar coordinates and the polar coordinate system. So the first type of question is, or concept is, complete the square. It is a concept examined in Algebra 1, Algebra 2, and we see it here again. So we're using it for the purpose of, well, finding the center and radius of a circle. And this is an equation for a circle, even though it doesn't look like it. So the very first thing we have to do when completing the square is group your x's and y's together. Group your x terms and y's terms, and then move your constant to the right if it's not already. So we have x squared plus 14x plus y squared minus 12y. Moving the 4 to the right, we would have negative 4. So now to complete the square, we take the middle term, what would be the b term, divide by 2, and then square it. So we'd have divide by 2, and then we would square. Okay, so that'd be 7. You square 7, you get 49. So you get x squared plus 14x. Again, we'd have 49. And then doing the same thing for the other term. We divide by 2, and then we square it. So we get negative 6. Negative 6 squared is positive 36. So we have y squared minus 12y and plus 36. So now when we place in these terms, to keep this equation balanced, we must do the same to the other side. So I have plus 49 plus 36. So that must be placed on the right side as well. Okay, so then that simple calculation, we get 81. So now, that's part of the completing the square. Now we group the x terms and the y terms, and we factor each. So the x quadratic piece becomes x, and the thing is, you already know what it's going to be here. What you get when you divide by 2, that's going to be what this quadratic equation factors to. So I divided 14 by 2 and I got positive 7. So this term factors to x plus 7 quantities squared. Which makes it really nice if you know that, if you remember that. And thinking of that, we would have y, and we got negative 6, so minus 6 quantities squared. Same thing here. And then equals 81. So this is an equation for a circle as we began with, but we can see what the center is. So we have a center of negative 7, positive 6, with a radius of square root of 81, which is equal to 9. Remembering that to get the center, we think what makes each of these groups 0. So negative 7, positive 6, and we always have to square root what this equation equals because this is r squared. So that's completing the square for this type of problem. Now looking at part B, same thing. The only difference with part B is you have your constant term, your 55 is already on the right side, but as you move it towards the left, you have to move the 10y to the left. So you're getting your x terms together, you're getting your y terms together, but your constant's already on the right side. And you should get, as a result, I'm not going to spend the time here doing this, you should get, as a result, for this problem, a center of negative 1, 5, and a radius of 9. So that way you can check your answer whenever you walk through it. And just trying to save time in this lesson so it's not really long. Looking at the next. So moving from completing the square, so the whole idea of a skill review is looking at all the skills we need to do this unit. So this is just another skill, using the sum and difference identity. So I'm going to put a link here for whenever I originally talked about sum and difference identity. So if you need to go back and look at that more, but let's see what we have. So we have cosine of 3 multiplied by pi plus theta. And the very first thing I encourage you to do is think of distributing this 3. This really isn't something that's it's optional. You don't have to do it. You have to distribute the 3. So we have cosine of 3 pi plus 3 theta. Okay. Now the sum, this is a sum. The sum identity for cosine is cosine, cosine, sine, sine. So cosine of the first angle cosine of the second angle. If I'm adding, if I have a sum, it's a difference here, so the sign changes. Sine of the first, sine of the second. And we just simplify with our knowledge of the unit circle, we simplify. So cosine of 3 pi is -1, so we have -1 cosine of 3 theta. Sine of 3 pi is 0, so 0 sine of 3 theta. Okay, so this second term is going to be going away, giving us, when this is all simplified and done, negative cosine of 3 theta. All right, so really knowing how to enter into the identity, and then from there you're simplifying. Let's look at the next. So the next has this 5 that we're going to need to distribute, but it has a 2 in the front, and that 2 is just going to carry down every single line. Okay, so I don't know if there's 4 lines here, we'll find out. So 2 sine of 5 pi minus 5 theta, okay. So the sign difference identity is sine, cosine, cosine, sine. Okay, so it's sine, cosine, cosine, sine. So 2 sine of 5 theta, cosine of, 5 pi, and cosine of 5 theta. With sine, if we have a difference, it stays a difference. So sine 5 pi, so now it's cosine 5 pi, and then sine of 5 theta. All right, so with that, we would have, well, 2 still in the front. Sine of 5 pi is 0. Cosine of 5 pi is -1. All right, so this front term goes away, giving us 2. The minus and the -1 turns to addition, or just a positive, sine of 5 theta. And there we go. So really the key thing with this identity is knowing what the identity is and entering the identity, and from there you're just simplifying. Right, moving on. So we also need to know, when looking at polar coordinate systems, how to solve a trigonometric equation. So we have solved these 2 trigonometric equations. So we're thinking of this not as 1 plus 6, which is 7, and then divide by 7. No. This 6 is linked to the cosine, so I have to isolate the cosine. So we think a simple 2-step equation. Subtract 1, which gives -6, and then 6 cosine theta. Divide by 6, we get -1. Okay, so we have cosine of theta equals -1. So to be technical, I'm going to write arc cosine of -1 equals theta, but often you'll just think of this like mentally. When is cosine equal to -1? Well, between 0 and 2 pi, the answer is only at pi. So looking at part B. So same thing, we need to isolate the sine of 5 theta. So just like we isolated the cosine, there's no addition, subtraction involved. So I just divide by 7, which gives us -1 sine of 5 theta. Now, when we first examined solving trig equations, when I had an inner function like this 5 theta, I deal with that after I take the arc, in this case arc sine. So after I find those initial angle measures, then I have 5 theta to work with. Watch what I mean. So sine, so taking the arc sine of -1 is going to equal not theta, but 5 theta. Okay, so arc sine is, so sine is -1 at 3 pi over 2. So being equal to, that's 3 pi over 2, but this is 5 pi. So when we have this multiple of theta, we need to continue our list. So we have this, and then let's see. Well, making 1 full rotation, that's so 3 pi over 4, 4, 5, 6, 7 pi over 4, or sorry, pi over 2, 8, 9, 10, 11 pi over 2, 12, 13, 14, 15 pi over 2, 16, 17, 18, 19 pi over 2, what would the next one be? 20, 21, 22, 23, pi over 2. Okay, so now we have 5 theta is equal to this list. The reason why we had to make this list rather than just saying 3 pi over 2, because you might be wondering, well, many of these are outside of this range, and you're right, but this is still 5 theta. So we have when we divide by 5, we get 3 pi over 10, 7 pi over 10, 11 pi over 10, 15 divided by 5 actually simplifies to 3 pi over 2. So notice when I divide by 5, we're still within 2 pi. And 19 halves divided by 5 is 19 tenths. Now when I divide 23 pi over 2 divided by 5, that's past 2 pi. Because even 23 pi over 2, that's past, well, if I divide, let me show you what I mean. If I do 23 pi over 10, 20 pi over 10 would be 2 pi, and that is outside of our range, so we would disregard that value. So we have this list of angle measures. And if you know anything about the rose curve, which this is a rose curve, 5 theta would mean that we have 5 angle measures, or 5 petals. That's what we're looking at. Okay? So moving on. So the last piece of this skill review is, given a coordinate, find the direction angle. So the direction angles we use when we convert coordinates in rectangular to polar. So there is a formula we use to do this, to find the direction angle. It is the arctangent of y over x equals theta. So we just do that. So theta, the direction angle, is going to be the arctangent of -2 over -5. Okay, so in our calculator we would get from that, say we are in radians, so I need to change that to degree. Okay, so we have in degree. So arctangent of -2 divided by -5. Okay, it gives us positive 21.8014, but we have to consider, does that match where our coordinates located? And the answer to that's no. This is in quadrant 3. This is in quadrant 1. So to get our angle to quadrant 3, we're going to add to it 180 degrees. That would take it to quadrant 3, which makes it 201.8014 degrees, and that is our direction angle. So similar, actually not similar, it's the same process here with this next one. So if I take this, so theta equals the arctangent of -9 over +1. All right, so show you what that looks like. So the arctangent of -9 divided by 1. We get from this, interesting, -83.6598. Okay, and that's degrees. Okay, does that match our coordinate? So 1, -9, that's in quadrant 4. And what's interesting is this negative angle measure is in quadrant 4. All right, so that's going to help. That's going to help us convert coordinates to polar. So this is just basic skills. I hope this helps you. And if you have not yet gone to the actual review for the unit, I encourage you to go there. I'll put a little link here on the screen. And guys, I'll see you then and in the next video.